Math Blast 29. I can multiply multi-digit numbers. 32 times 45. So I've modeled area model many times in which we find partial products. So I'm going to just set my problem up here as 32 times 45, looking much like the algorithm. And I'm going to do the partial products on the side. I'm going to take 5 ones times 2 ones and 5 ones times 3 tens, or 30. And then I'm going to take 4 tens, so that's 40, times the 2 ones, and 4 tens times 3 tens. So this will give me all the partial products. 5 times 2 is 10. 5 times 30, or 5 times 3 tens is 15 tens. That's 150. 4 tens times 2 is 8 tens, or 80. And then 40 times 30 is 4 tens times 3 tens, which is 12 hundreds. And now if we add all of the parts up here, we get 1,440. So the product, the answer to our multiplication problem, is 1,440. Next, solve using any method. So here we're dividing a 4-digit by 1-digit number. I'm going to model 4,215 using a place value chart. So I have my ones, my tens, my hundreds, and my thousands place. And I'm going to put 4 discs in the thousands, 2 in the hundreds, 1 in the tens, and 5 in the ones. And now I want to divide by 5, so I'm going to bundle those into groups of 5. Here, I don't have enough, so each one of these discs decomposes to make 10 discs. So each 1,000 is decomposing here to make 10 hundreds, because 1,000 is the same as 10 hundreds. All right, now I want to bundle those into groups of 5 because I'm dividing by 5. And I see I got 8 groups of 5 there. All right, and now I'm going to take the 2 that I have left here. These 200s that were left and did not bundle are going to decompose. I'm going to unbundle them and make 10 tens out of each one of those. And now again, since I'm dividing by 5, I'm going to make groups of 5. And I see that I have 4 groups of 5. And there's one of these tens that didn't fit into the groups, so I'm going to unbundle that and let it turn into 10 ones. Now, again, we're dividing by 5, so we're going to put these into groups of 5, and I see I'm able to make 3 groups of 5. So the quotient, the answer to my division problem, is 843. I can model equivalent fractions. Model 2/6. I'm going to do that first. So I'm given my rectangle here. This is my whole. And if I want to model 2/6, I see that the denominator, the 6 in my fraction, represents the units that we're dealing with. So I want to break my whole into 6 equal parts. And I'm going to shade in 2 of those parts. So now I've modeled 2/6. Underneath of my work here, I can see draw additional lines to create an equivalent fraction. So I'm going to draw some additional lines here to create an equivalent fraction. I'm going to draw 2 horizontal lines. We can draw as many as we want, but I'll draw 2 there. And now I can see that my shaded parts have become 1, 2, 3, 4, 5, 6 out of a total of 3, 6, 9, 12, 15, 18 parts. So 6/18 is a fraction that is equivalent to 2/6. And I can check that through my multiplication by a form of 1. I know that I can get from 2/6 to 6/18 by multiplying by 3/3 because I turned each part into 3 parts. So 2 times 3 is 6 and 6 times 3 is 18. But what I really did was multiply by this 3/3, which is a form of 1. And when we multiply by a form of 1, the identity property of multiplication says we're going to get what we started with. It's just written in a different form here. All right, let's go to our next box here. In the next box, it asks us to add and subtract fractions. We're going to add first 2/3 plus 2/3. If I have a fraction bar here and I break it into thirds, I can shade in 2 of those. I want to add 2/3 to that. So here, let me change my color here. I'm going to add 2/3. So there's 1. Oh, I need another fraction bar. We'll break that one into thirds so that I'm able to add on another third. So I started with 2/3 in the green and I added on 2/3 with the red there. And so now I have a total of 1 and 1/3 towards another whole. All right, and so now we're going to subtract. We're starting with 6/8. I'm going to have a fraction bar here that's using units of eighths. I'll break the whole into 8 equal parts. I am going to shade in 6 of those. All right, and now I'm going to subtract, and when I'm subtracting, I am going to, let's fix that there. When I'm subtracting, I'm going to take away 1/8. All right, so we have our 6/8 modeled, and I'm taking away 1/8, and now I can see that there are 5/8 left. So the difference is 5/8. Okay, on the back side, I can multiply a fraction by a whole number, write an addition expression using unit fractions to represent the shaded portion of the tape diagram. When I take a look at the tape diagram, I notice that the 1 is around this portion of the diagram. So there are 1, 2, 3, 4, 5 equal parts within my whole there. So the units are fifths. Each one of these boxes is representing a fifth. So I can say I have 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5. There are 6 1/5s there. Here, 1, 2, 3, 4, 5, 6 1/5s are represented in my tape diagram. All right, and now it asks for a multiplication equation for the shaded portion. And so I can see that I have 6 groups of 1/5, and 6 groups of 1/5 is equal to 6/5, or 1 and 1/5. I can identify and construct parallel and perpendicular line segments. Look at the figure below, identify parallel line segments and any perpendicular line segments, then classify the figure. So my parallel line segments, parallel means the line segments will never ever touch. And so I can see that MW here would never touch RO. So I'm going to say line segment NW is parallel, that's the symbol for parallel, to RO. Perpendicular line segments. Those are line segments that create right angles. So they intersect or meet at very special points that make right angles. So here I see MR is perpendicular to RO. And I will state that as MR, line segment, perpendicular, that's the symbol for perpendicular, to segment RO. All right, now it wants us to classify the figure. So we can see that it is a quadrilateral because it is a 4-sided figure. A trapezoid is a quadrilateral that has at least one pair of parallel sides, and we did see that it has a parallel side, a set of parallel sides. MW was parallel to RO. A parallelogram is a quadrilateral that has two pairs of parallel sides. Our figure does not have two pairs of parallel sides. And to be a rectangle, a rhombus, or a square, we would have to have a parallelogram. So the most specific name for our figure is a trapezoid because it has one pair of parallel sides, or I should say at least one pair of parallel sides. I can classify triangles by sides and angles. Circle the equilateral acute triangle below. So equilateral means equal sides, all equal sides, and acute means all the angles are less than 90 degrees. So I can see that I have all equal sides here and all the angles are less than 90 degrees. That's my equilateral acute triangle. Put an X on the obtuse isosceles triangle. An obtuse triangle has an angle that is obtuse, an angle that measures more than 90 degrees but less than 180 degrees. And I can see that here in this triangle. An isosceles means that we have at least two equal sides. So we have this side equal to this side. Obtuse isosceles is going to be, our obtuse isosceles triangle is going to be this triangle here. Oops, we're supposed to put an X on it. And that's all for today, math friends.